Good evening, everyone. I am Karthik Muthuviran, the executive editor of Construction World and Equipment India magazines. This flagship publication of ASAP Info Global Group. Construction World is circulated across 800 cities in India, and it counts among its esteemed readership that comprises of architects and builders, equipment and building material companies, EPC and engineering companies, and many more. It's an honor to welcome you all to today's webinar on an incredibly relevant topic, that is advancing pavement performance through functionalized polymer innovation. Before we dive into today's discussions, I'd like to take a moment to express my gratitude to Honeywell for presenting this insightful webinar in association with Construction World magazine. Next slide, Sunil. To kickstart today's session, we have a short presentation prepared by the Honeywell team. The Honeywell team consists of some very experienced and knowledgeable professionals. Our first speaker is Dr. Yong Hong Ruan, who is the Global Asphalt Technology Manager, Mr. Imanshu Patak, Product Manager, and Mr. Swapnil Kanojia, R&D Engineer. They will take us through how low molecular weight functionalized polymers can help contractors and engineers achieve higher pavement durability, improve workability under diverse climatic conditions, and support lower temperature, low carbon construction practices. So without further ado, I now hand it over to the Honeywell team. Over to you, Mr. Imanshu and team. Sunil, you can start the Honeywell presentation, please.
Sure. Thank you so much for that introduction, Karthik, and good evening, good morning, everyone. I warmly welcome to all the panelists, co-panelists, and also all the participants for dialing in. I'm sure this would be one interesting one because I can assure you, looking at the panelists which we have and also the way Construction World has organized this whole webinar. So stay tuned. There are so many interesting topics. There are so many discussions which we are planning to have during this webinar, which will be, which we all can correlate. We talk during different forums and different places. Before that, I hope you had a good break of Diwali and Chhat Puja. There was festive season all around. So I hope you had a good break, good, thing and charged up for the paving season, because this is the paving season after monsoon. It starts in India. I know the monsoon is not over yet, but yeah, okay, we can at least officially say that monsoon is over, and we'll start the paving season very soon. So the topic is, it is very interesting that the vision of our leadership and also as a country where we are heading towards making world-class and sustainable roads, right? Now to make that kind of achievement and to go and get these kind of accolades for our country, we need to re-engineer everything, almost everything, the practices, the materials, the kind of approach we do, the kind of skill we have. And so we come from the material side, and we have this expertise of doing with materials since last 15-16 years across the globe. We participate in almost all the markets across the globe, and we have seen different kind of road conditions. We have seen different kind of challenges. And in India also, we have covered the geographies across from Leh Ladakh with BRO till northeast, till west and south, till Madurai and Kerala. So we have understood the the whole part, what challenges we have. So we thought, why don't we come together and share and discuss, and if we can find some common path, we can take that along, right? So so moving ahead, if you can go to the next slide, please. Yeah. So till the time the presentation is loading. So the point is that we wanted to discuss some of the crucial challenges what we have, in our country. So like if I count it on fingers, the rutting and yeah, I mean, this is general disclaimer. We can move forward, Karthik and team. Oh yes. So this is so we are also participating before we delve into the detailed subject. So we are participating at Indian Road Congress at Bhubaneswar, which is happening from 7th to 10th of November. You all are invited. We have our booth there, and we'll be there. All the contact details and things are mentioned here. We would love to see you there and have a detailed discussion on any of the topics which we touched during this webinar or anything which you want to discuss as fresh. So yeah, moving on. Yeah, so like I said, so there are three major challenges. I'm not saying these are only challenges. Three major things which leads to rutting, which is one is the increase in traffic volume, increase in traffic load, and also now EVs coming in, they are heavier than the general vehicles. Now, why I say this as a challenge for India, because our economy is growing unparalleled to any other country. What does that mean? That means that we'll have more number of cargoes moving here and there. That means we'll have more number of loads going here and there at more speed. That's the target what our transport ministry has, right? Reducing the time between one city to another, carrying more loads on the same roads. So how to achieve that? And if you remember in the beginning of my presentation, I said we need to re-engineer so many things to go and get these kind of goals in real. So rutting is the problem which we have with our infrastructure today. And that is because our roads are not designed for that kind of traffic volume and traffic load, right? So we need to, one side, we have to regulate on what kind of traffic load and volume has to be on the road. But we all know in practicality, it is not that easy to, regulate and monitor and do all those things. Of course, there are efforts and people are working on that as well. But on the other side, as a road, paving industry, or, the people who are responsible for doing this, our job is to, make good roads who has lesser number of rutting. So this is first thing what we'll be touching through during our presentation, and we'll see, how can we solve these kind of problems. Moving to the next slide, please. Yeah. So, challenges are like, like I mentioned, from if we move to the North India and especially Northwest, we have, extreme summer in Rajasthan and also some parts of, Haryana, Punjab, Delhi. So we have higher temperature, even some parts of Maharashtra. Right. So and some areas which has harsh winter and snowfall, which are north and northeast in particular, and there are few areas which has highest rainfalls. Now we cannot have one single recipe which will suit to everyone. I mean, I'm telling it about any material, right? It could be any kind of material additive or the kind of design we do. There are a good amount of experience present in our co-panelist, and I'm sure they'll be touching all these topics around. But these are major reasons why some of these things happen when we try to fit one solution to all the kind of conditions. So of course we need to address that, and then we need to address on the symptoms and also find the root cause of these kind of problems, and then we need to go and do the diagnosis and address those kind of problems, right? So during our presentation we'll be covering and touching various topics, and we'll try to at least have cover some light on these kind of things, and also let you go with a thought where you can think and also can collaborate, and can also we can discuss on various topics which can reduce these kind of moisture damages or rutting or these kind of things going forward. Moving on to next slide. Yeah. So like I mentioned around world-class roads, and the second part was on sustainability, right? So decarbonization is something which is which is not no more a buzzword, which is not a green story which everyone wants to drive. It is the reality, right? So we have to have materials which are more energy we should have more energy conservation, and we should have more greener materials which should be coming, and more practices also which should have less carbon intensive, right? So that kind of things will also drive some of the innovations, and then elevation and the paving area and all those things which I mentioned earlier about the areas. So combining all these things together and challenges what I just mentioned, can we have a material which will be low carbon, and which should work across all these kind of climatic challenges, and also have lower carbon footprint when it comes to the production, and can solve some of these problems. So that is the topic which we'll be discussing throughout the presentation today. So from here, I'll be handing over to Yong Hong, who leads our asphalt technology for global. He has a PhD from Texas University in chemical engineering, and he'll be taking us through some of the things because of his global experience. He comes with so many insights. He has seen so many challenges across the globe, so he'll be able to touch few many things. And at the end of the session, if we have time, if time permits, we can take some of the questions. We can ask some of the questions to him, and if not, we can also put some of the things in chat, so that we can go through those questions in later stages, and we can definitely communicate back to you. Over to you, Yong Hong.
Yeah, please go to the next slide. So I think this slide is, I think, a very simple one, right? So very simple one. The title is bitumen is more than just a binder, right? So in the paving industry, a lot of time, we call bitumen a binder, right? So which indicate most of people in the industry will use the bitumen in the asphalt mix as a binder, which can glue aggregate together, right? Aggregate together. However, in our opinion, bitumen in the paving material is much more than that. At least two things we can think of is lubricant plus binder, And the reason we put the lubricant in front of the binder, right? Because in our opinion, we think the lubrication came from bitumen. A lot of times it's even much more, I think, more important than the binding capability of the bitumen. So we will, we in the next couple of slides we will show you why we say this. Okay. Yeah, here this slide show how bitumen act as both a lubricant and a binder, right? So this plot is a very simplified diagram of the entire paving operation, right? So first, at the asphalt plant, you blend the molten bitumen with the aggregate, right? Different size aggregate based on your gradation to produce the asphalt mix. Then you use a truck to transport the asphalt mix to the paving site, and transfer it to a paver. Then the paver will spread the asphalt mix as a thin layer at the top of the road, right? The foundation or the top layer. And then you have a compactor came in to compact the asphalt mix to certain thickness, certain density, or certain air weight. So actually you can say for most of the process, the production process, the transportation process, and the majority of the compaction process, right? So bitumen behave like a lubricant, right? And the bitumen coat the surface of the aggregate to make the flow and the moving of the aggregate easier, right? They don't stick together, and also reduce the friction, right? So even during the compaction, we want to have a low friction among the aggregate. So when you compact the aggregate, they can move around each other easily. So it'd be easier to achieve the density or the air weight. Only after most of the compaction is done, and after the road is open to the traffic, bitumen begin to behave like a binder, to buy the aggregate together, right? So to buy the aggregate together. So that's the reason we call bitumen is not, it's just, it's more than just a binder, right? It's a lubricant plus binder, lubricant plus binder. A lot of time actually the function of lubrication is even more important than the function of the binding from bitumen. Go to the next slide, please. So in order to meet those challenges Himanshu just discussed during the last couple of slides, right? So polymer has been widely used global wide to modify bitumen or to produce PMB, polymer-modified bitumen, to meet those challenges. Yeah, we have I think fairly good success, right? So by modify bitumen into PMB, use PMB to build a road. So the natural question to ask is, there are so many different polymers in the market, right? So which one I should pick? Or in another way to ask question, what is the ideal polymer for bitumen modification? Right? So in our opinion, ideal polymer used to modify the bitumen should not only increase the bitumen stiffness or the PG grade or the viscosity, you can name it, and the modulus at high temperature, right? So warm climate temperature, because it will give us better rotting resistance. It should also improve bitumen's lubricity, because we just discussed bitumen behave like act as both a lubricant and a binder, right? Binder. We need the lubricity from the polymer. So with a polymer which can improve or increase the bitumen lubricity, it will reduce the frictions among the aggregate, right? So when you do the compaction, you can do it at a lower temperature, compaction, and also you can potentially reduce the mixed the process temperature at on the plant to produce the on the aggregate mix, and also with improved bitumen or PMB lubricity, it will help or to facilitate the reorientation of aggregate during the compaction to achieve optimized aggregate packing structure. We will show you in the image, actually real image we took in the lab from the core sample, how Honeywell to help to optimize the aggregate packing structure, right? So we will end up with more stone-to-stone contact point or contact zones, right? So when you have more stone-to-stone contact point or contact zone, you will end up build a stronger road, and less rotting, and also better longevity. Go to next slide, please. So here is the very famous straight-back curve. Straight-back curve used for the field of tribology, and the lubrication, oil lubrication. So here what we did is we tested the COF, coefficient of friction, COF, for 3 bitumen. The middle red color, that's a base PG64-22 base bitumen. And we use this base bitumen to produce 2 PMB. They're both PG76-22. The top one, that's the PG76-22 modified with an elastomer or SPS here. And the bottom one, the orange colored curve, is also a PG76-22, but modified with Honeywell Titan 7686. So it's a low molecular weight functionalized polyethylene. So that's the chemistry of Honeywell Titan 7686. You can see actually across a fairly wide range of the Hersey number or Straight-back number, right? Straight-back number, that's the x-axis. The PG76-22 containing Honeywell Titan 7686 has the lowest COF. lowest COF, even lower than the base bitumen in the middle, right? So PG 64 minus 22. In general, when you add some traditional polymer, especially the elastomer, like SBS, into the bitumen to produce PMB, the COF, you can see here, right? So COF will increase, increase. That means the friction when you move the aggregate around during compaction will be high. So that's the reason you need to use, compared to the base bitumen, when you switch to PMB with SBS, it will require higher production temperature and also higher compaction temperature, right? Because of the higher COF. Go to next slide, please. Yeah, one more click. Okay. So with the improved lubricity from Honeywell Titan in the PMB, actually what we found is this better lubricity will help to optimize the hot mix adsorbent aggregate structure. To the left, these are two image high resolution digital camera image we taken on a couple for core sample compact in our lab. What we did is we will use like a diamond saw to vertically cut the core sample into small pieces, around like maybe 1 centimeter in thickness. Then what we did is, you can see here, I can show you the white colored area, those are aggregate, right? So with different size, you have a larger aggregate, you have a smaller aggregate. The black colored area, those are either bitumen or PMB or airwood. So what we did is we use the software called IPS2, actually take the, we use the high resolution digital camera first to take the picture, digital picture, then we use the software called IPS2 to actually count the stone to stone or the rock to rock contact point out of certain cross-section area. So, in our study, we use the 10 centimeter times 10 centimeter, right? So that's a dimension of the square. So the total area is 100 square centimeter, right? 100 square centimeter. So our software will be able to help us to count the number of stone-to-stone contact. We call it contact zone. And also it can measure the length of each contact zone, right? So the software, and then add all the contact lengths together, give us a total contact length. We will discuss this more, I think, in the next slide. So just a couple words. The similar chemistry made by Honeywell, similar to Honeywell Titan, actually has been used as a lubricant for PVC extrusion to reduce the friction, right? So in nature, this polymer, they can help to reduce friction. So actually, yeah, this slide, thank you for moving to this would be my last slide. Here, what we did is we prepared 3 PMB, and also we prepared the core samples. We took the image, we used the IPS2 software to count the number of contact zone and also measure the contact length. You can see we did a PM, they are all PG76-22. We did SBS PMB or hybrid, that's in the middle, SBS Honeywell Titan 7686 PMB, and we use a Honeywell Titan only PMB to prepare these core samples. So the table shows here, that's the first 2 columns, those are contact zone, number of contact zone, right? So that's how many stone-to-stone contact our software find, right? So you can see for SBS, out of 100 square centimeter, you have about 5,800 of contact point or contact zone. And then the hybrid actually has the highest, almost 9,600, and the Honeywell Titan only solution, about 6,500. And similarly, contact length, you can see SBS is about 30 to 100 millimeter. That's the total contact length. And the hybrid is about 5,000, and the Honeywell Titan only is about 3,700. To the right, what we did is we plotted total contact zone number versus the routing. So we also did a hamburger routing test on this core sample. Then we try to correlate the routing of the sample versus the total contact zone number. Actually, we have a fairly good linear relationship. The higher the total contact zone or contact number, the less the routing, right? So R squared is 0.881, so almost 90% R squared. So that tells us actually, if you have a more stone-to-stone contact, or which we call the contact zone or contact point, you have a less routing, although you will build the stronger road. Will have a less on the failures and the better durability. So this is the last slide of my presentation. Now I will hand over the presentation part to my colleague Swamnil. Swamnil, please go ahead.
Yeah, Swapnil, just one request. We need to, looking at time, we need to speed up a bit. I think we have taken a bit more time than the assigned.
Sure.
Thank you.
Yeah, can you move to the next slide? So you have heard about the problem statements and how Honeywell Titan can help us to address some of those. So now let me take you over to some of the specific case studies across the globe. So the case study you see is a case study from Las Vegas where Honeywell Titan hybrid formulation was used for laying of Formula One racing track. So here the problem statement was to lay the track with higher PMB grades, due to which the viscosity was shooting up on the higher side, and we were also the customer was also failing to meet the creep recovery as per the standards. So approach what team followed was that we did some in-house lab work which resulted in optimized dosage of hybrid formulation, which helped to achieve the required specs with keeping the viscosity in limits, which further helped in the ease of paving and helps to enhance the workability at the site actually. So can you move to the next slide? So yeah, so this case study is this was conducted in the northern region of India with with one of the highest altitude region, that is approx 17,000 feet, and where temperature ranging from around -25 degrees Celsius to 35 degrees Celsius, and there we executed with BRO, that is Border Road Organization. So due to being a mountainous region, the two major problems what we have understood there was, first, the low temperature cracking, and second, the difficulty in paving due to the low temperature of the bituminous mix. And these major causes were because of two factors. What we see are extreme low temperatures, and the location of HMP or HMA plants at longer distances from the site. And one of the major defect of one of the factor was, during the snowing season there, the truck movements or the convoy movements of army is done through the chains on their tires to avoid the skidding, but that leads to the cracking of the road at intense level actually. So team's approach was to understand the target specification, which led to the lab work to optimize the formulation based on Honeywell Titan to address this low temperature cracking, and also help to pave the road at even drop temperatures actually, with a drop temperatures bituminous mix. So after all the lab work, the stretch was laid and site was under observation for approx 1 year. As you can see the photographs. So we revisited the site and to look over the performance, and which showed that performance is on the positive side, and which can be also seen on some of the surface photographs taken. And we also regularly do the core cutting on the sites or on the sections what we lay to have a close look over the performance, or if any deterioration is happening, then what are the root causes on that. So now actually the photographs you see, they were taken in last September. Now the stretch has been intact even after 2 years, and we have also got an official report from BRO on the performance of the stretch. Can you move to the next slide? Yeah, so this is one of the case studies which was conducted from in Texas DOT. So this was a paving project which was done in Texas with Department of Transportation, where a stretch was laid to observe a comparison on the paving production temperatures and also on the roller passes which can be reduced with use of Honeywell Titan. As you can see, and a significant decrease in the operational temperatures, which results in lower emissions of some of the emissions like SO2, SOx, NOx, and various others. So all these emissions were calculations were done by a NAPA gas calculator. Actually, we have used that gas calculator to do all those emissions calculation, that how much reduced emissions can be done if we do operations at even lower temperatures as the current industry is going on. So and for any further more discussions or for any further more details, we can even connect offline actually, or even if we are traveling to IRC, we can meet there and we can have a a detailed discussion on the slides. Maybe you can go to the next slide. Yeah. So at last, I just want to conclude, and maybe Yong Hong and Himanshu can pitch in where needed actually. So the conclusion from the whole slide states that bitumen it not only acts as a binder, but it also acts as a lubricant. So so bitumen can be taken as both as a lubricant and as a binder. And how Honeywell Titan helps to overcome some of the problem statements is that it increased the bitumen lubricity. It also helps as at the lower it helps to increase the lubricity, which results in optimized aggregate packing, and which helps which connects to the building stronger and durable roads. And at lower temperatures, if you can do the operations, that will obviously help to reduce the environmental emissions at last. So anything, Yong Hong and Himanshu, if you want to add in this?
No, I think we are good. And if there are any questions, and there are some questions in Q&A box, Yong Hong and Swapnil, if you can have a look and reply to them. And like Swapnil mentioned, and I also said that we are at IRC, we will be happy to see you. And if you want to reach out, we have our contact details shared already. Over to you, Karthik. And sorry for some lag and delay.
No issues. Yeah. Yeah. So thank you very much to the Honeywell team for that wonderful and insightful presentation. It was a great introduction to the cutting edge technologies and applications that are paving the way for a more sustainable future. So now moving on to the core of today's webinar, our panel discussion. I am truly honored to introduce our esteemed panelists who bring in a wealth of expertise and experience to the table. We have Mr. Biswabikash Raut, who's a senior manager at L&T Construction. We have Dr. Rajiv Kumar, the scientist, Flexible Pavement Division, CSIR, Central Road Research Institute. We have Mr. Muthu Annamalai, who's the Vice President Projects at Vertis Infrastructure Trust, and Mr. Himanshu Pathak himself, who's the Project Manager at Honeywell. This session will be moderated by Mr. Vijay Agarwal, Managing Director at Equirus Capital, who will guide us through this important conversation. Over to you, Mr. Agarwal.
Yeah, thank you, Karthik, and thanks everyone for joining for this session. And it is a very important topic of a pavement. We always, because all of us are riding our vehicles on the road, and we are always worried about the quality of roads. And I'll try to just dwell upon the very few burning issues in the sector, and we can take. So I can directly come to Muthu first. Muthu, always this overlay intervention is a very touchy issue. And what I understand, like in developed countries, you have a very less, or maybe this time between two overlays is much higher than India. Is why it is so? Why we are having so much frequent overlay requirement compared to developed countries?
Thanks, Vijay. This actually, there are 4 or 5 elements into it for this frequent overlay. So I will touch upon one by one. So actually, it is a need of our also. Because of frequent overlay, we are losing the natural resources also, aggregate and other things. So normally in developed countries, they design the highway for 25 to 30 years period. But in India, we are designing the highway for 15-20 years period. So design itself, we are restricting and we are doing for the shorter period. And overlay also generally on average, if you see, in India, we are doing the overlay in a span of around 6 to 7 years period. But if you compare the outside world developed countries, it is around 12 to 15 year period is there between overlay to overlay. So it's almost double the Indian frequency. So there are factors involving is like Himanshu also earlier notified the vehicles are overloaded. So vehicle overloading, because of the overloading, some project in our portfolio, the vehicle damage factor is ranging between 50 to 60. So if the damage factor is very high, it is definitely the road, whatever the quality you build, it will try to fail. So some restriction has to be there on the overloading. Otherwise, it is very difficult to control. One part, it is not only overloading, the other parameters also there. As the lot of circulars are there for the usage of material, lot of code practices are there. But even though so many code practices and other things are there, still people are using the wrong bitumen. If the surface temperature is around 70 to 75 degrees centigrade, so they use a lesser temperature withstanding bitumen like VG40 or VG30 people are using. If they use VG40, definitely it will not take that much temperature. It will soften and it will try to have a rutting and other issues. So selection of bitumen also is one of the problem. And selection of aggregate also sometimes it's a problem. So aggregate, that angularity is not there. Sometimes stripping value is there. If stripping value is there, the bitumen will not get coated properly and the life of the pavement will be very, very short only. And apart from design and selection of material, the mix design also matter. After the mix design, execution is the major part. Even if you do all these things properly and during execution, the control is not there, then the entire scenario is going to fail again. So in developed countries, the quality control measures are very stringent. Here also now it is improving. In India also it is improving, but not everyone is practicing. There are some exemptions are there. So when I was one of the material engineer in one of the project, we have constructed the road. The road last almost we only resurfaced 20% of the area in 15-year period of time. So
That's great. Like
it depends on the stricter quality control norms and other things. So if everything goes well, then we can also have a longer period. If you go for a longer overlay interval, then only the minerals, materials, everything can be saved. Otherwise, during our period, we finish all the hill, we will finish all the natural resources. The future generation will have a problem.
Yeah.
So it is a combined effect from everyone, from the product supplier to the quality control design. Everywhere it has to be coordinator and it has to be executed. Then we can have, it is not, in some of the road, it is still standing 10-15 year in India also, but on average, it is 7 year, 6 year overlay is happening.
Yeah. No, I agree with you fully, Matu, that this overloading and definitely the quality of constructions and these things play a lot in this case. And when I had dealt the roads, so I had seen the quality of road before I sold them, and after that, how it has been maintained by the people like you, and how you people do the quality controls and everything. So yeah, that's a good. I'll come to Himanshu now. Himanshu, since you had also made a presentation on the new age material, I want to See, what are the new technologies developers can use to reduce the maintenance and extend the life of overlay? Any thoughts on how the pavement design should be done, considering the locality, region, rainfall, temperature difference? See, many like I remembered I went to a inspection for a road in Rajasthan, and then you had a temperature like daytime the temperature will be like a plus 30, and night it will be like 4 or 5 degree, and then you have so much variation. And I was told that that was the one of the reason they used the CRMB, and then that cracks came because it was not a right material there. So if you can just throw light on the new age material which can be used for pavement design. Over
Sure.
to
Yeah, thanks, Vijayji. So I think you touched a very interesting topic, and like I mentioned during beginning of my presentation, that we are an evolving economy, right? And we have challenges on the go, and we have to build solutions on the go. So only request and only thing which I'll have to everyone is that be open to the experiments. Unless and until you experiment something, we cannot just tailor fit some of the solutions which are working in some of the other countries, right? Like you mentioned about Rajasthan, very interesting topic. Now, the kind of, the temperature variation what we have in Rajasthan is unparalleled to, I think, 60-70% of the world, right? Because we don't have a place where in summers temperature goes up to 50 degrees C, and in winters it can go into minus also, right? So now we have to select a material which can withstand in both those kind of environmental conditions. And also, in last year, I think we experienced and we saw a good amount of rainfall happening in the same area. So now, having a proper design and having this thing. So these are some of the challenges. So now this wrap coming in, also there are so many materials, not only Honeywell Titan, there are other materials also. And I'll just request one thing, that be open to those kind of experiments. Try to experiment what solution fits to that kind of problem, what can solve those problems, rather keeping just one biasness in our heads that we are using this or that material since so many years and it is doing the job, so we continue to use that, right? Because that will not solve the problems, because now the challenges has also evolved, right? We had different kind of challenges, like I mentioned during beginning of my presentation, that now we want to reduce the distance between one and two cities. Now we want to have more axle loads. Now we want to have more number of vehicles running. So now we have to change to new materials, go for the new solutions. And only thing which can help with this is experiment. There is no magic recipe. There is no just one material which you put in the bitumen and problems are solved. We have to experiment. We have to do some trials. We need to understand which solution is working for which problem. And then accordingly, we can take next steps.
Okay, thanks, Himanshu. I'll come to Mr. Raut. Now, Mr. Raut, see, FWD surveys are very important for pavement design. We always do the FWD survey, and then we design the roads. Then there are guidelines like IRC 115 guidelines, which use the conventional overlay materials. Guidelines are related to conventional overlay, but now there are changes in the material like CTB and CTSB, cementitious bitumen layers are coming. So how you see these guidelines impacting the design and uses of these new materials in the pavements? Mr. Roth, you're
Yeah. I have unmuted now. Sorry. Thank you, Karthik, for inviting me for this webinar, and thank you, Vijayji, for that very insightful question. So, FWD, as we know, is the most used technique for pavement evaluation in India. So, basically, everyone must be knowing what FWD is. It is basically a impulse loading on a circular plate, which we give to simulate the traffic loading, and the deflections are measured, and which is further used for back calculation of the modulus values. So the FWD technique that has been evolved uh, for a particular temperature range in our country. So the temperature range for which it was developed is around 20 to 45 degree centigrade. So, but our pavement temperatures now are going very high. If you see, our temperatures are going beyond 60, 65, 70, 75 degrees across our country. So there has been a constant urge why we cannot do the testing at higher temperatures. FWD testing is restricted to temperature below 45 degrees. So I'll just like to add a few pointers to it, because the philosophy of FWD design is based on the elastic theories. So beyond a particular temperature, these elastic theories won't work. So that is why it is not possible for us to conduct this FWD testing at very high temperatures. So you are asking about what are the improvements that can be brought into this codal guidelines because of these new materials being introduced. The first thing that I see in these guidelines is the FWD evaluation that is being done. It is being done for a 3-layer system, right? But now we have advanced materials, we have innovative materials, we have RAP, we have bitumen stabilized materials, which are used as intermediate layers. So how to incorporate those layers in FWD analysis, how to take advantage of these materials in FWD analysis is still a question. But if you see globally, there are softwares where FWD analysis are being done in multiple layer theory, where we can use the seed modulus of different layers to analyze the pavements. So that is one thing which is being used globally. And secondly, the temperature correction models that are available in IRC 115 as of now, basically they were developed for conventional binders. So I have a thought that when we're using this polymer modified bitumen or other improved products, these binders are much less susceptible to temperature changes. So the temperature correction models that are there in the code may not be very much applicable to the advanced bitumen that we are using, because they are very less temperature susceptible. So that also needs to be relooked. And coming to CTB, CTSB, the code does mention about CTB, CTSB usage, but it takes a very conservative approach, where it says that you treat it as a granular layer. So it is not actually, we are not actually getting benefited out of it. So at L&T, we had constructed India's first composite pavement actually in Matlampati bypass in NH7, where we had used the equations, whatever is given in present IRC 37 for designing that road. So when we did the FWD analysis and we used EverCalc as a software to actually back calculate the values, actually the values were very well correlating with the site results. So these softwares can be explored, and there are FHWA guidelines which very well let us compute the modulus values. Actually, it gives the modulus values, and then we can reduce the modulus values based on the cracking area and also all these things are there. But how to adopt it for Indian conditions needs to be studied and researched.
Thank you, Mr. Raut. I'll come to Dr. Rajiv Kumar. Mr. Rajiv Kumar, now we were discussing about the new technologies, how new technologies are coming and evolving. And I wanted you to throw light on like how your organization is recommending uses of these new technologies. And another point, see, all of us are now using the latest materials, improved materials. But recently, I think in one of the TOTs, NHAI has also moved up where they said, okay, you have to do the overlay based on the BBD values. You will do the test, and then accordingly, if it requires a overlay, then you will do it. But I think this was a change, like 2005-7, there was always a overlay which was every 5 years, and then they shifted to BBD values. But in recent one of the TOTs, now in the TOTs, they are again prescribing time specific interval for the overlay. Can you throw light on these two issues?
Yeah, thank you very much, sir. First of all, I will make the clear that why the pavement is getting failed. During the construction, we are designing the pavement for two distresses. One is rutting, another is fatigue. fatigue occurs in the bituminous layer that we consider as the top bottom of the bituminous layer. Right. So whatever the strain we have targeted, right, we have the perpetual pavement, right. So every pavement or at the bottom of the bituminous layer, what should be the strain that we are calculating, and the real also we are calculating the traffic, and someone is giving the excuse that we have not, it is a heavy traffic, then it's their mistake because they have not simulated the traffic, right. So they have not done the design of the pavement correctly, right. So that is the fatigue. Now second is the rutting. So rutting has not considered in the bituminous mix. Rutting strain is coming on the top of the subgrade, right. So top of the subgrade, there is a one strain value is there, right. So there is a two condition. Is there fatigue problem or it's a rutting problem? Most of the time in India, rutting is occurring not due to the subgrade, it is due to the bituminous mix. Most of the national highway and expressway. Now, this is the two reason. During the construction, I have designed my pavement for the strain on the bituminous bottom and the top of the subgrade. Now coming to the overlay technology, the BBD, right, Bunker-Man beam deflectometer, IRC 81, right. So there is no problem. Problem was that in the NH, like if I will talk about the rural roads, in one JE, under one JE, junior engineer or AE, they have 20 kilometer to 100 kilometer road under one JE or AE, right? They are very well, they are very well capable to do through the BBD. They will have no problem, right? So for them, there is no problem. And for the guidelines also, there is no problem for the overlay. Now coming to the NH, NH have the problem with the BBD, they take more time. And the data is also the ball, whatever the deflection we need, we are not getting because we have the number of layers, different layers. So we need the modulus of each layer. So we come up with the FWD. In FWD also, like Rawat sir has explained that have the different method, and we are adopting five layers, 4 layers, 3 layer technology. Software we have, and in India, everyone is using it. It is not that only 3 layer system we are adopting for CTB and CTSB. We are adopting 5 layer for software. But in IRC 115, it is not revised. It is going to be revised, right? Now coming to the overlay, like why the overlay is required. If there is a problem in the subgrade, we cannot go for the overlay. If the problem in the GSB, we cannot go for the overlay. If the problem is the base layer, WMM, we cannot go for overlay. If it is problem in only the bituminous concrete or the DBM, then we can go for the overlay in the certain condition, right? So what condition we can go for the overlay, that we have to decide, right? So that is the main concern, right? So like nowadays, so new technologies like traffic speed deflectometer is coming with like GP, your FWD plus your GPR plus NSB, all three combination. Recently in India it came, right? So I hope if all three will come in one vehicle, then more data will be visible, right? Because in one single equipment, they are going to give you the GPR, which is not uniform, like FWD. In the case of FWD, what is the problem? If they are going for overlay, the thickness of the layer, it is not uniform, and they are getting the whatever the thickness is given by the client, and they are getting the analysis done on the based on that thickness, right? And the modulus is different. If the thickness is different, your modulus will change, material is changing. Every 20 kilometer material is changed, right? That is the maximum I can say. Minimum, it can be the 1 kilometer, 2 kilometer also. So main is that don't go the new technology. New technology is just for the okay, for marketing, but the concept is same. Any technology, the basic concept is same, right? So if you will go for the concept wise, then use any technology smartly, it will work. So that is my suggestion or request that everyone should follow the guidelines 100%, not only the limited one, which is only advantage for them, right? If they will you go for the 100%, smartly, knowledgeable, right? They have everything and it will work. FWD is also working, there is no problem. But just as Himanshu said, so told that overlay is not a solution for all the problems. It is only for the bituminous layer. So thank you, sir.
So, yeah, Dr. Saab, so like now all of us are talking about the sustainability, reduction in uses of the material. So why NHA is moving away from this performance-based metrics to again a fixed time metrics? If you are, see, suppose we are all using the new age material and which gives you a life of 15 years, 20 years. And if they prescribe you to do the whole every 5 years again, then you are wasting the material. Even if
No,
it is the
now,
whole is not required, and then also you are wasting the material then.
now
What's your
coming
view on that?
that is the their decision. My view will be that we have the perpetual payment. The life is 50 years, and the perpetual payment overlay can be done every 10 years, right? With what if it is required, right? So in same condition, if it is required, then overlay should be done. Otherwise, it is the benefit of the contractor or maybe who are the beneficiary, right? That can be done, and I think it is going to be implemented. And some of the project it has been they have requested, and it has been given to the contractor. So slowly, it will come. And regarding the sustainability, Muthu sir was telling that aggregate demand. So in India, if you will see, aggregate demand in the construction are almost 1.2 billion metric ton is there. And if I will tell you that USA using almost 120 million ton RAP, right? 120 million ton RAP. This is not the new data. 2022-23 data is there. And due to that, they are saving almost 6 million metric ton of bitumen, right? And we are the second largest road network. And how much bitumen we are consuming? 8 to 9 million metric ton annually. See, they are getting 6 million metric ton from the RAP. And you know how much they are using the bitumen? 30 million ton, right? And we are using 9 million metric ton. And we are saying the second largest road network because we have 70% roads are the rural roads, right? So still China is also using almost 24 million metric ton of the bitumen. India, we are using only 7 to 9 million metric ton annually. So it is not that we are using the accessing material or we are accessing the aggregate. Now coming to the RAP, right? If India has started, CRI has already constructed in 2021, 60% RAP we have utilized. And now people are using almost 50% RAP in DBM. BC, we have used almost 40% RAP, right? Bituminous concrete, top layer. In DBM, many project has been implemented, 32, 50, and 60% also because the double barrel plant is required. And in India, we have almost 7 to 8 double barrel plant, right? 5 is from Amman and 2 is from 2 or 4 is the other. So total maybe maximum, I have 8 data. So maximum it can be, we can include as 10 double barrel plant is there, hot mix plant. So if we are using the RAP, only RAP, so we can save 2 to 3 million metric ton of the bitumen, right? So 30 to 40% bitumen we are going to save and aggregate 100%. So if you are using 50% wrap, right, not go overlay. In Delhi, they have banned, they are not going to go for the overlay. Whatever the material you mill it, reuse it, right? So aggregate is 100% saving, bitumen extra saving, right? So, and rutting will be not the problem. Problem will be the fatigue, crack. And if the crack is coming, it will be visible on the top. So the quality will be maintained, right? If there will be problem in the lower layer, it will be not visible. So people will not catch, right? They will do the micro surfacing, problem solved. But here it's a problem. So smartly, if they are using the wrap, it can be done. Right. Other materials is also there, like sustainable material. So like steel slag is also one. So steel slag, India is the second largest. But if you will see, the China is producing almost 1,000 million metric ton, right? And India is producing 100, right? So we have almost 19 million 19 million metric ton of the steel slag, right? So how much road we can construct from the 19 million metric ton? Maximum, as per my calculation, 400 kilometer. And you know how much kilometer we are constructing? NH we are constructing almost 20 to 40 kilometer per day on an average, right? Next, NRIDA, PMGSY road, rural roads, they are constructing almost on an average 100 kilometer per day, 100 kilometer per day. And other agency like Panchayati Raj or other government agency as a state government, PWD, they are constructing around 20 to 30 kilometer per day. So almost 200 kilometer per day we are constructing the road, right? And if you will tell that how much more time we are going to construct, so maximum this phase will be 2030-35 maximum, right? Then it will be like a China, they have constructed most of the road in 2014 only, right? So India is going to be achieve that step. Then we will the most of the fund will go on the maintenance, right? So like whatever the NH has implemented the toll tax, right? Right. So that also going to be improved, right? So slowly the problem is coming and solution is also there, but the solution coming to the field, it is taking too much time. It should take less time so that it will be visible. So I hope in the coming years, whatever the technology we have, if you cannot find any technology which don't have the IRC code. If IRC code is there, it means it is technology is five years older, minimum 5 years older, right? And whatever the technology in India we are adopting, in USA or European countries or Canada's, already they have constructed successfully, right? We are just validating, right? So validating is not the problem, much problem, right? Because if you will see the temperature data, USA has done that $50 million project, right? For getting the only temperature, ambient temperature and the pavement temperature. So we are taking worldwide, all the countries taking same data, right? India is also getting, but we are validating. The NHA has given the project to CRRA, so we are validating it, right? So there are many technology and most of them are success, but technology, most of the technology handled by first time, they have faced the problem. Many contractor has faced the problem, and given that we have used the first time, so that's why the problem came. And if you will use next time, all the problem we have understood, and next time it will be not the problem. So whatever the some of the problems are there, that due to the one of the reason that they have due to the lack of the knowledge, I can say that problems came. But in coming years, all the problem can be taken by the contractor, NHI, and the research organization.
Thank you, Dr. Rajiv Kumar, for such a detailed explanation about the pavement designs and the recycled material like steel slags to be used. I'll come to Mr. Muthu again. Mr. Muthu, I think this overloading is a big concern.
Yeah.
And one way to look from the asset owners like you is a overloading
Yes.
versus repairs requirement. Basically, how much you earn, how much you spend, and so whether it makes commercial sense on that. And secondly, we are also hearing about this pavement failures. Like we had a recent press on the media that Delhi Mumbai Express is certain stretch during the rainy season, or maybe after 2 months of the start of the road, then the potholes started coming there. Can you just throw light on these two aspects?
Yeah. Regarding the overloading, actually, all the money is not coming to the operator or something like that. If it is a HAM project, money goes to the NHA and the problem comes to the concessionaire. In case of old agreements, also, whatever the overloading money collected will go to NHA and the concessionaire has to face the overloading problem on their own. Only in the recent agreement, concession agreement for toll collection, it goes to them, but it is not viable. Whatever you, if 100% of the vehicle are overloaded, then maybe you can get more money. From that money, you can repair. But if you are few vehicles damaging your road, and you will be getting little bit money, but that may not be sufficient to take care of your maintenance. So that is on the overloading part. And Delhi, Mumbai, I just came to few of the through some of my friends and report. Actually, the SMA, they have done the SMA. So SMA is really, it is a old technology in other country, but we are trying now. So when they are trying that, whatever the aggregate size should be 1/3 of the thickness of the whatever layer we are laying. So there, I think they used around 50 mm thick layer. So it's supposed to be 17, 18 mm thick should be the bigger aggregate they should have used, but they used around 13 mm aggregate, I think so. And the quality of bitumen, the polymer-modified or VG40, I do not know exactly. So that bitumen also, they used a little lower grade bitumen, so it was not withstanding the temperature. So these 2-3 parameter affecting the SMA. On some other area, some failure is due to the construction, that speedy construction, maybe embankment layers not compacted properly or something like that.
Okay. Thank you, Mr. Muthu. I'll come
Yeah.
to Mr. Himanshu Patak. See, India, we have a lot of area, Himanshu, which is a hilly region. And always we will have this landslide problems, the pavement impact in the due to landslides or weather condition, because you talked about the BRO roads. Like BRO roads, the temperature like Ladakh, it will reach to -40 also in certain season. So how we should see how we can avoid this distress on the pavement in hilly region, because see, that becomes a big news items. And again, if you go to these regions, the people really suffer if you don't have a good quality roads. Anyhow, you are on a hilly region, and if road is not good, then your rides are like bumpy rides.
True.
Yeah, Himanshu, over to you.
Sure. Yeah. So I think that's a very interesting point, and I'm sure Biswaji or Rajiv and Muthuji will echo with me. Is that the approach what we follow for the roads what we are making either in Mumbai or Indore or Hyderabad or Chennai will not work in the hilly regions, right? So it starts with the design. So the kind of design what we do during the hilly region, I'm talking from specifically from two recent experiences point of view. One is BRO, which we just showcased. There is another one, what we did between Shillong and between Guwahati and Shillong, right? So that those kind of stretches where you have in 40 kilometers there are close to 500 sharp curves and turns, right? So now for that kind of road, we have to start from the design point of view. Like we have to have right design which can address which can address some of the hilly, terrain challenges. So keeping that in mind, if the road is designed, and then the appropriate bitumen selection, and then the material selection, like which kind of material you want to have. Like if you want to go with the PMB, which kind of additive you want to go ahead with the PMB. And then the most critical step, I think Muthuji mentioned, is around the quality check. So even though if you do all the things, you do the good mix design, you do the right material selection, you do the right bitumen selection, but if you're not controlling the quality, and if you're not if the workmanship is not up to a level where we can achieve some of these things, then all your efforts will go in vain. Now, having said that, how to approach these kind of roads? So I go back to my previous discussion. Like, we are building more number of kilometers or more number of miles of roads in hilly regions now in since last 10 years compared to what we had built in last 50-60 years, right? So now we are building, and now we are realizing, okay, there are some challenges. This is not working, that is not working, like I mentioned. So some of the practices which were working in some of the markets which we are some of the areas which we are where we have more number of kilometers and highways may not work in the hilly region. So for that, what we need some of the unbiased experiments there. We need to experiment and try with the new materials and see whether what is working, what is not working. Like I mentioned about Northeast and some of the projects with BRO, we had certain. It is not that 100% of the areas and 100% of the things just came on the plate and we put some magic recipe and it worked. It was like, okay, we experimented certain things. We experimented it. Then, like Biswa mentioned about the doing the FWD and collecting the data and understanding what is there and what kind of approach we should follow. And then through that, we were able to achieve what we have achieved since last 2 years. I'm just saying about Titan here, right? Honeywell Titan. I'm not talking about the other materials. I'm sure the similar approach can be followed through other materials, and if that is unbiased, I think the if we all come together from design to bitumen selection to PMB material selection to quality check and finally the execution point of view, I think that can be addressed. We have seen this getting addressed where the intent is clear and where all the points are coming together.
Yeah, thanks, Himanshu. I'll come to Mr. Raut. So Raut, now we are all using this modified binders at project sites. But like Mr. Muthu said, that how we are using this new age material in the site is very important. Can you throw light on how we should use, what are the problems are faced, and how we can mitigate them of using this new age material? So Raut, you're on mute.
Yeah. Thank you, Vijayji, for the question. Vijayji, L&T was one of the early adopters of modified binder in India. So all the 4 airports that we did from 2008 to 2012, all the 4 international airports, that is Delhi, Mumbai, Hyderabad, and Bangalore, we used modified binder. So we have seen the evolution of the modified binder specification from a more empirical viewpoint to a more rheological based approach, what we're using now. In fact, recently only we have completed our 3 airport runway projects where we have used polymer modified binder. So over a period of time, what we have seen is it is not fair to see only the binder in a silo. It has to be attacked in form of a mixed design where we have aggregates, where we have binder, where we may have to add some other additives, so that we have a mix which restricts the type of failure that Rajiv ji and others have been following. So we at L&T have mandated in last 2 years to ensure that during the mixed design stage, we actually fix the threshold values of some of those parameters. So we fix those values and we try to monitor those values over a period of the entire project, be it rutting or be it fatigue. So it is done in the lab level. So you can call it in a sense a balanced mixed design approach which is used. Also, we try to focus to bring about some of the material properties which is included in the Super Pave guidelines to strengthen the mixed design parameters, especially as Muthu sir was mentioning about angularity. So it plays a very important role in ensuring we have rut-proof mixes. So that is one thing that we have been doing. And at site also, we are trying to augment this use of this performance-based design with simple performance tests. Now there are tests with which you can identify very quickly at sites the mix is prone to rutting or not. So though we don't have Indian specifications for them, but still we have in-house developed some guidelines which can be followed at project sites. So we are maintaining a data of it, and the performance of the mixes, we are seeing a drastic improvement over. And if not improvement, if we are able to identify any problem, because it is mandatory for all those mixes to be tested every month for their performance properties in L&T. So if we are able to identify the root cause, we are able to find a solution to it. And also at site, people are more now oriented or more sensitive towards the small changes, like what a change of 0.1, 0.2% binder content can do, what a change in little source of the aggregate can do, what a change in the aggregate angularity can do. So they are also now more sensitive because they are seeing the performance test data with them. So that is one. Second challenge that we have been facing, especially using polymer modified bitumen, and I think Honeywell and other modifier manufacturers can also help in this, is the drastic drop in temperatures that we see in polymer modified bitumens, especially in our runway project sites where it is a vast open area and we have to pave 24, 30 meters of pavement. So the temperature drops very fast. So that's why the paving operation has to be completed very quickly to ensure proper compaction. So I think companies like Honeywell or other polymer modifiers can actually put a thought process to this, how this temperature drop can be minimized. We as contractor do our part. We try to use insulated vehicles, covered vehicles to ensure that temperature drop is reduced. But yes, a better product can help us actually perform much better at project sites. The third and last point that I would like to share is this dynamic shear rheometer testing. Okay, it is a more scientific method of testing and it gives rheological properties. But how many contractors have that? And it is only the manufacturer's MTC that we are relying upon. And also we don't know how much polymer is being added, because the quantum of polymer actually plays a vital role in ensuring the properties and the longevity of that product. We don't know how much quantum is being added because we don't have a particular test. Though tests are available, ITR spectrophotometer tests are available, but who does that? So actually what we do is we have a person at the contractors, at the producer's plant, and they calibrate and see that it is being added. So that is the only way that we are able to control it. But if something is put in the code saying that, no, you have to do this particular test to find out the amount of SBS or any type of binder which is there in the bitumen, that would play a major role in actually controlling the product, controlling the quality of the product at the site and improve construction. So that will be from me. Yeah.
Thank you, Mr. Raut. I think I'll just put one very, all of us staying in the metro faces this question of potholes. Like Delhi election, it was a big issue. Bombay, we face first rain and then we will start seeing the potholes coming on the road. Any one of you would like to take this question? Why in the city roads we always get these potholes, and what are the remedial measures can be done? Any one of you?
The if the water is getting contacted with the bitumen mix, then the problem will start. Water should not stand in the pavement first of all. Water is the first enemy to the bituminous pavement. In one of my project, we have coated the aggregate with plastic, dry method of using the polymer. It's polyethylene waste plastic. Whatever waste plastic we used, and we have coated the aggregate with that plastic, and then again bitumen has been injected, and we have taken in the normal plant only with the manual feed of plastic, and we laid the road. 5 years on the national highway main carriageway, there was no pothole actually, because if the plastic gets coated over the aggregate, it acts as a layer. So it doesn't allow the water to contact with the aggregate, and reaction is being stopped, and the pothole formation is less. Practically speaking, Maybe Dr. Rajiv can give more idea on that.
Dr. Rajiv, over to you.
See, sir, first of all, I will give one example. Rural roads, the construction cost was 3 years back around 60 lakhs. New construction per kilometer, almost 5 meter. Right. Now the construction FDR, you know very well, the FDR is very popular nowadays in rural roads, low volume roads. The construction cost is 1 crore rupees, right, per kilometer, and minimum it's a 1 to 1.3 crore rupees per kilometer. It requires heavy vehicles, big vehicles. The cost is around 3 crore, 2 to 3 crores, right? It's similar to the hot mix plant, almost the smaller hot mix plant, right? Now coming to the one is the hot mix plant, right? How much time they are giving to the contractor in the Mumbai? They are giving the sufficient time? Answer will be no. Which equipment they are using? Slower one, right? So they will not go for the quality control, right? The problem is from the both side. They are not giving the time and they don't have the equipment, proper equipment. They are going most of the part like Muthu sir was telling that plastic. If you will go for the plastic road construction, dry methods, eight extra levers is required for the fitting. Feeding the plastic, we require minimum 8 levers for feeding, right? If you will not give the 8 levers, they will not put the plastic. In the front of you, they will put, but if you will go, they will not put. They will save the labor cost. For them, it is very quite easy. It's a maximum they can save 2,000 rupees for labor, but your quality will be, right? So my problem is the main problem is that there is a problem in each step. I will not tell you that only one step. Each step, they are not giving the time. Contractor have no technology they are using, which can give you the the equipment they don't have, right? The materials which is required, like anti-stripping, like bonding, right? If you will see the USA, if there is a flooding on the road more than 2 hours, the heavy vehicles should stop. But India, it is not stopping, right? So that is based on the traffic regulation, right? So in the from the car, there will be no damage. If it is flooding, if there is any condition due to the car, no road is going to fail. No distress will come due to the car if the road is constructed well. If it is distressed road, then it will be gone, right? But if it is flooded for one days, right, 24 hours, right, then it's a problem of the another problem, right? Road can sustain the water maximum 4 hours, 6 hours, right, with limited traffic, right? Is the government is doing, like Said Muthu sir was telling about the toll plaza collection, right? I will tell you honestly, right? Government is getting the money, right, from the sand, from the any other, whatever the peoples are there, from the truck, right? They are getting the money. We are getting the money, right? And that money is more than 3 times. More than 3 times, which we required for the maintenance, right? Right. So it is not the problem, right? It's how we are sharing the things, how we are adopting, how we are it's I can say that if it will be open, quality will be controlled and everyone will be happy, right? And slowly it is coming. I will not tell that it is not coming. It is most of the project it is coming. And the Mumbai, I will tell you, in the Pune, one of the roads are there, right? They have constructed and they don't have the single pothole, right? But they have given the sufficient time, sufficient materials they have selected, right?
JM Road, Rajiv ji.
Yes, I was not telling the name because I thought, it came in
Yeah,
the news, but there are more few roads are there, right?
yeah,
So they have constructed, many contractors are there, they are well qualified, right? They can take the challenge. If you give the money, right? Give the money for 20 years, they will not give you the single pothole. But things should come, but it is not that in the same money only. How much money they are giving for the maintenance, right? I will not come the NH, but I will come for the rural roads, right? In rural roads, the maintenance is annually is 1 lakh rupees, right? That's why they are not going for proper maintenance. And then after 5 years, they will go for the FDR, 1 crore rupees, right? In the bituminous layer, we required only 10 to 15 lakhs, right? If they will go for 30 BC in the rural roads, they will have sufficient life, more than 10 years. No one can blame on that, right? But we are not doing that on the maintenance on the time, then WMM and GSB is getting affected because see, WMM and GSB have no any problem. If I will ask anyone that what is the life of the soil subgrade, everybody will agree that the life of the subgrade is like infinite, right? CBR is not going to change if it is not stabilized. If it is unstabilized, then it will be infinite, more than 20 years, right? If what will be the life of the GSB? Infinite. There will be no problem. If it is achieved the 98, 97% compaction level, how much it is going to be densified? What will be the problem in the WMM? It will be not the problem. Problem is that we are allowing the water to go inside the WMM. If it will go in the WMM, no one can stop, right? So stop the water to go under WMM, most of the problem will be solved. Don't delay, right? Whatever it's not the pot falling, do the overlay, right? Stop the water to go under pavement, under the WMM layer or whatever the base layer is there. I think pothole will not come.
Thank you, Dr. Rajiv. I think I'll just do the conclusion of this webinar. So just as a summary, I'll say that I think new technologies are coming up for like a traffic speed deflection meter, so which blend the FWD, NSV, everything, and then give you a better reason, help you to design the roads much better. And I think the new age material which are coming, so we should see a better road life, delayed pavement maintenance, and I think Rajiv ji also said that timely repair of the potholes so that it doesn't allow the water to seep inside the pavement and damage the WMM and everything, then we can increase the life of the project. And all the riders who are paying the toll tax or who are paying not paying toll tax, both of them can enjoy a better ride on Indian roads. And so another point is like how we can reuse the material. I think I used to see one vehicle which was a European. I'm talking of 20 years back, and which is still being used. I've not seen a single vehicle which is stripping the road, mixing there, and laying. So it was a constant trailer. The machines were entirely loaded in the trailer and it was being reused. So the same aggregate, they were adding the bitumen in that and then making the BC, and then the paver was behind. Material was being transferred to paver. Then you overcome the challenge of the temperature loss, the quality reuse of the existing material, you reuse of the bitumen, you reduce the bitumen. Another thing which I have also seen is like in Australia, they use this block techniques. Wherever a pothole is there, they cut the road and just put the block and then seal it. And I think we are using this new technologies on Indian roads and which can really reduce the cost of overall maintenance life, maintenance cost of the roads. And I once again thanks all my panel members for sharing their insights on such a hot topic. And I thanks Construction World for inviting all of us for this event. Over to you, Karthik.
Yeah, thanks a lot. Thank you to all our panelists and to Mr. Agarwal for moderating this insightful session. We appreciate your valuable insights on how low molecular weight functionalized polymers contribute to building high performance, sustainable, and durable road infrastructure. We've received a lot of questions, but I doubt if we have time to take up the way, as we've already shot up by time by 30 minutes. I would like to wrap this up. I would like to thank everyone for joining us today. A special thank you once again to the Honeywell and Construction World magazine for making this event possible. I wish you all a wonderful day ahead. Thank you.
So just one point here, Karthik.
Yeah.
Thank you so much
Yes,
for
sir.
that. If you can share all those question answers along with the
Sure.
participants' email IDs, we will just send those replies
Yes.
back, whichever we.
I will do that.
Yeah.
I will do that, Himanshu.
Sure.
Yeah.
Yeah.
Thanks, everyone. Thanks for
Thank
joining
you.
us.
Thank you.
Thanks all.
Thank you.
Okay,
Thanks,
thank
everybody.
you.